Hello everyone, this is Bradley. So previously I've made this kind of spline tracer exploding whatever animation. So originally I was intending to other things, but I finally failed. So I ended up doing this. And I've thought about using different methods in animation nodes to approach these kind of questions. And I think it would be better to use simulation nodes instead of using other methods. So today this is mostly going to talk about recreating this method, but also to discuss why other methods that can also use to do kind of spline tracer does not really work in this particular case. So let's start. So the first method that people usually do is to use a node which is called a Falloff tracer. Okay, this node is a part of extra nodes, so you have to have extra nodes so that you can do this kind of stuff. And this here is kind of a very routine setup of this Falloff tracer. You can simplify this one as using the distributed matrices. But here, what I want to really show you is this is the result. If you look at the larger scale, it looks very, very cool. And you can either change the iteration, or you can trim the spline to trim all these splines so that you can animate the entire animation. But what I want to really ask you to realize is this is the sphere that we use to generate the position for our starting point of our tracer. If we disable this sphere, you can see all these kind of trace is going in the same direction. So and then later expand out. So if you look very far away, it looks kind of very cool, very nice, very chaotic. But the issue is, what if I want to have chaotic at the most beginning? So you can tweak a lot of these values to see its effects. For example, increase the steps, it becomes more smoothing out. Increase the iteration, it just expands, more chaotic. But just full knowledge that you can also change the amplitude or other things. But in whatever cases, whether you increase the frequency or other things, you either disrupt this entire thing chaotically, like this is completely crap. Basically, you have really no method to actually change the initial position without disrupting the terminal parts. Maybe there are some modes that can work, but it's kind of complicated. I do not really would like to discuss that. It's also kind of difficult to manipulate at this moment. So I personally do not really like use Falloff tracer in this particular case. Basically, if you would like to go small scale, I do not recommend you to think about this unless you do not care about the central part. But if you go large scale, this is a very quick and dirty method. Like you only take 4 to 5 nodes that you can get the result immediately and be able to animate the entire whole thing. So if you try to create a scene, an atmosphere, then this method is really, really good. That you can pan your camera around, like going across all these splines. I don't know what you want to do, however. But this is really a method. So here's another example that we are using a node from Blue Fox extension, which is called a Spline Tracer. You can download the extension from the link in the description just to make sure that you already install the animation nodes and so on and so forth. Okay. So here what it does is basically we're randomly generate vectors from this vector wiggle node, and it has been pointed out with all this kind of red marker. As I'm playing this animation, that you can see the spline is generated to trace the movement of all these kind of red dots. Here is just my theory about how this spline tracer node is doing. Basically, at this current frame, like our 46 frames, we're storing the information of the spline so that we use it to generate a new splines in the next frame, depending on the movement of our vector wiggle. So this node does work across the timeline. Okay, but the issue is that you are storing the information of a spline. There's many other information that you do not store, and this node obviously does not provide the ability for to store this information. This node is good because it's, if you're working with spline, whether you're tracing the random vector or you're tracing the particle movements or other things. But on the other side, this node is very limited because it's only working for splines. If you are working with other things that changes across the timeline, this node cannot really help you anywhere. Okay, you need to use other nodes or other system or whatever. So today's main topic is to talk about a more general ways to work with, to make kind of spline tracer, along with the ability to work with other things across the time and work with specific animation. And also to notice that currently for this particular spline, it does not give the results that's as my previous animation. So I'm not sure if it's possible at some point, but it's kind of, I'm not sure. Maybe if you're trying to emitting particles and trace the particle, use particle system from objects and particle info, particle data, and use that location to drive, maybe you will get a better result. I'm not exactly sure, but you can try. But our whole point today is to try to use an alternative method, which is called simulation nodes, which is part of extra nodes. So here we're in a new fresh file, and I have a simulation input. This is actually the only node that exists in simulation node, because simulation node is more of a system that's enable you to freely do whatever you want, instead of the spline tracer node that we earlier see that it do a particular job for you. Everything is already prepared. You do not have customizability on the top of this node. Okay, so basically you just type a simulation, and this is the only node that you find. And this node might be looks kind of very tricky, because this kind of dark socket is very barely seen in any kind of cases. It's probably you will only use that when you're using simulation nodes. What happens if there is a case that you always see that you do not know what does this socket do, what's the data type, you do not know what to input, you can always select the node, hit W, and it goes to data input, and select the socket. It will give you kind of sample input that you can get, and this time you get a set structure element. So what is structure? So if you search a structure, there is a combine structure, create a structure, get a structure list, set structure elements, and so on and so forth. The structure element is basically, I would say, a data block that you store the information. This is actually very similar to geometry nodes attribute system, that you have a list of value like a position, and you basically store information in a data block which is called a position, or P, or S, or R, whatever things you name that. And we will see this effect very soon. So here, just to follow what I would like to do later, is I'm going to create a sphere and scale it down, and then I'm going to use object mesh data to read our sphere, and also distribute mesh. So take the mesh and into the matrices. So there is two ways to create these kind of inputs. One way is to hit this plus icon and you take the vector list. The other way is you directly plug the things into the input, then it will automatically generate everything with the same name. So this is kind of very convenient, and it depends on the input that you generate. Usually I would just keep the name as they are, but it depends on how many. For example, I need to take another matrix list, which you do not want names to have conflict to each other, because it's necessary to be very specific. Okay, so once we know we set the structure element and input that to simulation node, we can output these everything. Within this linkage, I'm not sure if you can actually put the data to data, but this is not something I would do. Usually what you get is you have the input, you have the input of struct within the simulation systems. So within the simulation system, you first need to get the data. It's like you have a lot of attributes in geometry, but you need to decide which attribute you can actually get from the system. So this time our attributes is called a matrix list. It's called a matrices. So the data type is matrix list. So unfortunately, this is something that you have to know. So it will say name does not exist, but it will tell you, however, there is a matrix list type information which is called a matrices. So you just need to match the name so that you actually get correct data from outside the simulation nodes. So within the simulation nodes, you need to take back the matrices to output the simulation. So in this case, you again set matrix elements. I'm just going to shift D to duplicate these entire things. Orange to orange, and struct to struct. So this socket is no longer matters. Actually, it does not exist there. I don't think this is there anymore usage. So you do not necessarily connect anything for this guy. Okay, so this is kind of basic setup. What it does is, so initially you're putting a information into the matrices, and then you run the simulation. The simulation will run, and at the last it will output this new information, and then this matrices information will go back to the most beginning, and you run this loop ever again. Okay, so that's basically from frame to frame this data is changing its value. Before we head into actual production, I would like to do some troubleshooting. So now although this node tree does not really work anything specific, it's just kind of dumb things. What's in becomes what's out, and looping this over and over again. But try to play this animation, and immediately you will see the name matrices does not exist while everything matched, and this was not the problem at the most beginning. So what happened? So this is a troubleshooting 101. Personally speaking, because I work a lot with audios, so my sync is always sync to audio. But this does not work for simulation, because the simulation always work on the information from the last frame. If there is any frame drop due to whatever reason, either due to frame dropping or sync to audio, it will not work. This even occurs in rigid body, soft body, and so on and so forth. So you always need to switch that to plain every frame. A very bad part is that you always, when you're working with simulation nodes, the execution time is not very horrible, but the frame rate per second is very horribly low. This is unfortunately a kind of issue within simulation node. I'm not sure if it can be improved or whether it will be improved in the future or not. And another thing is basically I can do nothing. This is not my issues. There's nothing I can do. But we will talk about the cache in the system later, because this frame rate is really difficult to make an animation. Our animation intends to trace the spline, so we also need to create an attribute for spline. So you just take a spline list, make sure everything doesn't match, and it says name spline list does not exist because the starting frame is 1. You can also change that to 15. Then we'll say the names matrices does not exist until frame 15. That's the simulation node starts to run out. Okay. So this is kind of thing that you need to know. Next thing that's basically this is kind of when we have all this kind of information, I'm going to do a kind of very special thing. There is no a special theoretical background about why I'm doing this. Basically, I'm going to offset matrices. The reason I'm inputting matrices inside of a vector, what people usually will do, is because these matrices will include information like normals of our mesh, so that I can only input a single value instead of vertices locations and vertex normals, 2 values. So use 1 value to install 2 value inputs. In this case is what I need. Although in simulation node we need to do some conversion, but I think it's fine. And then I'm going to use the Berlin vector noise. Also to know that for some reason that this node sometimes breaks, for I do not know the reason. If this node does not work for you, go to presets and search for Berlin vector noise, and you need to check the linkage from this place. It should maybe it's broken for whatever reason, but just if it's broken, just link them so that this preset will work. Then we need to put a vector. I'm going to put the matrices in. It will automatically generate decomposed matrices. And then we put the second vector, which is actually the noise, into the place. And I'm also going to change the translation into local axis. And then once we have all these kind of points, we need to regenerate the splines. So here what we're trying to do is add add append point to spline. And the issue that you will realize is that if you put the splines, it will get this element. Basically, this is always a sign that you need a loop. So let's hit W goes to loop through spline list. So once we have the splines, we also need the vectors. So set up a vector list. So we need to put the matrices into vector lists. It will automatically convert itself to decompose matrix. And then we output this spline. And then put the spline list back. So now nothing happens, but if you try to play this animation, nothing happens. There are basically two reasons why this does not really work. One reason is this spline is just a data, it's not an actual object yet. So you need to take the curve object output. So put the spline list into splines and output a target object. Another reason is that previously we created a spline list, but we do not have anything within this spline list, and animation nodes will not really create this automatically for you. So we need to fill list and link the spline back so that you set everything to spline. So you at least need to use an empty to hold the actual object or the data. And then for the length is the length for our matrices that we have. So you can either use vertex locations or vector or matrices. It does not really matter because these have the same length. So once we have this, let's see what do we actually get. So we get the result immediately, and you can see how this spline actually goes. The frame rate, however, is very horrible, but it does work very well. And another thing is looking at this, how this animation has been created. It's kind of very interesting compared to the Falloff tracer, because we will stop here. Because it is spread out at the most beginning of this entire simulation, and it's very kind of smooth because we're using Perlin noise based on every location of the vector. Okay, so this kind of, I think this is kind of very cool, and because this is spline, so there is a eevee automatically generated for these kind of things. Just for the time being, I'm going to deduplicate this target so that we have a mesh being created. This is one way of caching. That's you duplicate the object and then you can try to trim the splines afterwards. So we need to create a new node trace, trim the spline, doing the animation. The important part of using a very critical reason that we're using this simulation method is rather to have the mesh on our hand instead of using the simulation to really animate anything. Because you have many ways of animation, but to create a certain kind of mesh is only limited to specific methods. Okay. Here I also want you to realize one thing. So within this simulation input and output, there is no anything that's being keyframed or animated. The only thing that has been changed is the frame number. Okay. Because whatever we're trying to do is, actually I've discussed this earlier, this is kind of loop. You're putting anything into data to the end, and this data will be fed back to the most beginning, and you run this loop over and over again, and everything has been changed based on this frame number. Okay, so if you try to trim the spline, what should you do if you trim the spline? Okay, so this is the thing that you need to think about. What if I would like to trim the spline? You do not necessarily to animate anything if you're trying to trim a spline. So a very easy way is just to trim spline without an animation, because the animation will be automatically done within this loop which across the time. So you can take the trim spline node, but this node does not receive multiple inputs, so you have to put within the loop. So since we already have a loop, you just put that in, it will automatically connect everything. So you take that to 0.1. So every time our spline will be cut down for 0.1. So what you can see at right now is that our spline has actually been trimmed. So you can see initially it's connected to the sphere, but now every frame it will be trimmed by 10%. So the initial region has been already disappeared. So this is one way that you can trim. Another, so what if I would like to offset the trim? So in the first frame, I do not want it to be trimmed, but it will disappear laterwards. So you can use the compare number and use the time info to see from which point it starts to be trimmed. In that case, you need a switch. For example, if the time is after maybe 20 frame, then this spline should be trimmed. Otherwise, it should not be trimmed. So this is so if it's true, then it should be trimmed for half. If it's false, then it will just trim for 0. So you can take this as a trial. So just to save the performance, I'm going to take that to 5 so that we see. So it goes to first frame, second frame, nothing changed, but after fifth frame, everything has been cut down half. So let's make it a little bit obvious, and then we play the animation. So nothing has been changed unless at the 50 frames, suddenly it starts to trim itself, and you only have this kind of particle things being spread out on these splines, which is kind of very interesting effect. Actually, this is also interesting. So you need to always use this kind of time info, compare number, switch to deal with this and that. Unfortunately, I cannot really presentize these things because there are so many data types you can potentially put in these things. I will consider that, but I don't think so. Just for knowledge that in the future, if there is I think very soon I'm going to release the new preset library 2.4. Maybe it's pre-release or whatever. There will be a spline tracers. Actually, it does not present at 2.92. So anyway, so there will be a preset to do all these kind of things for you. So you just drop a loop, the preset which is called spline tracers. Then you will get everything being done. Currently, it's not being finished yet. Okay. So this is kind of idea. Next thing I would like to talk about is the cache. So because we know these kind of things. So one method of caching, as I explained already, is that just duplicate the mesh. But there might be other cases that you cannot duplicate the mesh or sort of things. I don't know what kind of simulation can really work in addition to this spline, but I suppose you can do a lot of things with that because there are so many applications of Houdini solvers. But in this particular case, I just do not have an idea yet. I might show that later. But currently, what if we would like to cache a system within simulation nodes? There's nothing directly being provided here, but the animation nodes always has a caching system. Basically, you just link whatever to the group input. So you just want to make sure everything is things are in the group input. There's also a thing that you need to realize is that object instance node. If that's exists by any chances, you cannot put that into the group. You cannot put that into the group input. Then it will cause errors. So you need to be able to manage all these kind of things. But you just link one, you do not even output anything. So technically speaking, so within the advanced setting, within advanced setting, you can have the cache. Usually, cache per frame is the things you want. Okay, so this is the things you want, and you can clear the cache and do whatever things. But here's one issue that if you try to play these animations, it does not really work. So let's firstly delete this kind of trim spline because I do not think it's useful at this moment. Okay. So here we started from beginning and we try to add these splines. It does work very well because, and it's kind of caching, but one thing that you need to know is that if you try to replay this animation, it does not work. There are several things that you need to know is the caching system does not cache the creation of object. And we do have a creation of objects which is in this curve object output. So what you need to do is basically just output the splines and cut the linkage, put these splines curve object outputs out, and then you can start to cache, and immediately we get everything back because we output this spline list, and you can run this simulation. So now we have finished the entire caching. So there are several things I want to call your attention. So how do I know that my cache is successful? One part is the execution time on the left upper corner. So previously you may realize the execution time is constantly about 50 milliseconds. So this is one part. The second part is, as I said earlier, that when you are working with simulation nodes, it's always based on the last frame. That's why you cannot use the sync to audio, frame dropping, and so on and so forth. You have to use play every frame. But in this particular case, we can directly pull our timeline to the last second because it's cached, so you no longer need to work with all this kind of play every frame. You can switch to frame dropping. It will basically have no problems. But you also need to realize one thing, that the frame per second has not been really improved a lot in this particular case. I guess there are some reasons behind that you can just not improve everything in this case, but I don't know, because our spline might also be intense. If you try to look, there are so many points being generated, and my laptop, it really sucks. So there are so many things that you need to consider, and as I said earlier, you have to manage the methods to approach your problem by yourself. For example, earlier I said, oh, we have a duplicated mesh. So since we're caching these things, we can select these objects and duplicate this. And so now we have a more chaotic mesh, which looks kind of very cool. You can animate making shaders or whatever, rotating that. There are tons of things you can do. Another thing is that the cache will be rewritten once you change any values within that. There is so many possibilities because so far we haven't worked with seed, amplitude, frequency, so many things you can play around. I definitely understand the pain that you have to deal with low frame per second or other things, but I think it's worth for you to play around and using these methods, and be hopeful that perhaps this will be improved in the future, and so on and so forth. And just to say that once you duplicate all this kind of mesh, you need to, I hope you're working with another node tree, so you need to disable your execution within these node trees and create a new node tree to work on all these kind of new splines to train that, and so on and so forth. But I'm not going to show you how exactly to do that in this tutorial because I think that this tutorial is already very long. So basically this is it. So I hope you enjoyed this tutorial. I'll probably see you next time. Bye bye.